Welcome to qnawire.
We're going to follow the notation and derivation of equation 11.9b. And we're going to start with the general definition of angular momentum, where angular momentum would be equal to sigma sub I, or sigma starting at I, of the position times the linear momentum, or the cross product, rather, between the position and the linear momentum. So we can then express the position and the velocity with respect to the center of mass. So we can say that here, r sub I will be equaling r sub cm plus r sub I star, where this would be the position of the ith particle, essentially. So the first or second or third, so on, with respect to the center of mass. We can then say for the same thing, the linear velocity where v sub I star, this is coming from, we could say that it would be the linear velocity of the ith particle with respect to the center of mass. This is coming from differentiating the relationship here, and we can say that L, the angular momentum vector, is equaling the sum of r of I cross product with the linear momentum. This is going to be equaling the sum of the position vector cross product with the mass of the I particle times the velocity of the I particle. And so this is going to be equaling the sum of the position of the center of mass plus the position of the I particle cross product with the mass times, or the mass sub I times v sub cm plus v sub I. And so now we can say that this is going to be equaling the sum of the mass sub I r sub cm cross product with the velocity sub cm plus the sum sub I mass sub I r sub cm cross product with the velocity sub I star, and then this would be plus the sum sub I times m sub I r of I star, and then again plus the sum m sub I r sub I star cross product with v sub I star. And so we're going to note that the center of mass quantities are not dependent on the summation subscript, so they can be taken outside the summation process. So we can say that here the angular momentum vector would be equaling the position of the center of mass cross product with the velocity of the center of mass times the sum sub I m sub I plus r sub cm cross product with the sum sub I of the mass sub I v sub I star plus, and this would be sum sub I m sub I r sub I star. This would be with the cross product of the velocity of the center of mass, and then plus sum sub I times m sub I r sub I star cross product with v sub I star. And so we can say in the first term, the sum of the masses is simply going to be equal to m, the total mass. And then we can say in the second term here, we can say that the sum of m sub I v sub I star, this would be equal to the sum of m sub I times v sub I minus v sub c m, the center of mass. This is equaling the sum sub I m sub I v sub I minus the sum starting at I of m sub I v sub cm. And this is going to be equaling essentially the sum starting at I of m sub I v sub I minus the total mass times the velocity of the center of mass. We know that this is going to be equal to this is true from the definition of the center of mass velocity, where the velocity of the center of mass is equaling 1 over the total mass times the sum of m sub I v sub I. So in the third term, essentially going back here, so in this term here, we find that we can say the sum of m sub I r sub I star. This is going to equal the sum m sub I r sub I minus the position of the center of mass. This is equaling sum of I m sub I times the position sub I minus the sum of m sub I times the position of the center of mass. And this is going to be equaling sum sub I of m sub I r sub I minus the total mass times the position of the center of mass. And we know that this is also equaling 0. And this is true from the definition of the center of mass, where the position of the center of mass will equal 1 over m times the sum of m sub I times r, the position of that particle. And so we can then find the angular momentum. This is going to be equaling the mass times the cross product between the position of the center of mass and the velocity of the center of mass, plus the sum sub I m sub I r sub I star cross product with v sub I star. And we know that then the linear momentum is equaling linear momentum star plus, this is essentially for the center of mass, and then rather simply for this term would replace this term, and then plus again here position of the center of mass plus the total mass times the velocity of the center of mass. That is how we would prove that equation. That is the end of the solution. Thank you for watching.